Hey guys, welcome back to another video. Now that we finished our authentication system, let's work on authorization using strategies, guards, and custom decorators. At the moment, we do not have any protected queries or mutations, meaning all our queries and mutations are accessible even though we do not provide a valid access token. Let's change it. In order to test our authorization system, first of all, let's create another test query here in our auth resolver. And this query just returns a string. And we name it hello. And it returns just, for example, the string hello world. So far, so good. Going to our GraphQL playground here, we can test it, right? We can run the query and we get back hello world. By default, all our queries and mutations are not protected. And in order to test our authentication and authorization, let's make it that by default, all our queries and mutations are protected. And how can we achieve this? We can apply a global guard to our NestJS application. This guard will only allow to perform the query in case we have provided a valid access token. First of all, let's create a custom decorator called public. And this custom decorator, whenever it's applied to a query or a mutation, we do not need an access token. Okay? So meaning whenever we put this custom decorator called public, for example, we put it above the hello query here, right? Then this thing here would be accessible without an access token. All right, let's work on it. For this, in our auth folder, let's create another folder and let's name it decorators. And here we create a file called public.decorator.ts. And here we export a function called public, which returns set metadata. And the metadata we want to attach is called public. And we set it to true, like this. And here we go. This is our public decorator and how this public decorator can be used in conjunction with a guard, you will see in a bit. Next, let's create another folder in our auth folder called guards. And in it, let's create a file called accessToken.guard.ts. First things first, we have to use the injectable decorator here. And then we export a class and we name it accessTokenGuard. And this access token guard extends auth guard, meaning it gets all the functionality of the auth guard here. And we are also able to override functionality, so we can override methods and stuff. And yep, so far so good. And here in our access token guard, let's make use of the constructor. And we can do dependency injection here. And of course, here we have to call super, because we are using a child class, right? This is our parent class. And here it's complaining. Of course, I need to import it. And I can't import it automatically. That sucks. So let's import it like this. All right. And of course, I need to install this package here, npm add NestJS/passport. All right. So don't forget to install this dependency here. And now here in the constructor, we can do dependency injection. And we need to make use of the reflector class, reflector, which we also have to import. And why we need this reflector thing here, you will see in a bit. Don't worry. And now we need to override a method called getRequest. This is very important. And the reason why we have to do it is because we are using GraphQL, right? So we need to create a GraphQL context. We can't use the standard HTTP context. And for this, getRequest here gets an argument. We name it context. And this is of type execution context, which comes from NestJS common. And then here we can create a new context by writing GQL execution context create, and we pass in our context like this. And then we can return our request object, from ctx.getContext.request. And now again, we can override a method from our Auth parent class here. And this is the canActivate method. And here we can check now, const is public is equal to this reflector dot get all and override. And here we pass our is public string in, comma, and then we pass in an array. And here we can pass in our handlers as well as a complete class. Context get class like this. And now we can check whether is public is true or false, and then we can return true. So let me explain to you what's happening here now. Since we created the public decorator called public, we can use it on handlers, meaning we can use it on single mutations and queries, or we can use it on a whole resolver, right? So going back to our resolver, we can decorate single mutations or queries, but we can also decorate the whole Auth resolver, for example. And here we basically check whether a given query or mutation is decorated by this custom decorator. And if so, it has a property attached to it called isPublic. And this is, of course, true then, because in our custom decorator, we set it to true, right? So we attach some metadata here. And then in our guard, we can check for it. And whenever we return true from canActivate, it means that our query or mutation is public and it's not protected. And yeah, for the case it is not public available, we can simply call the canActivate of the parent and pass in the context. So what we've done here is we have overwritten the canActivate method. Yeah, we have access to a canActivate method because we are inheriting from Auth, and Auth has a canActivate method. And here we check whether a given handler, meaning a given query or mutation, is decorated with the public decorator. If so, this thing here is true, and then we return true, meaning the query or mutation is available without an access token. But if isPublic is not true, meaning it was not decorated with a public decorator, we call the canActivate method of the parent. Yeah, we call it from Auth. And in this case here, there must be a valid access token with a valid signature which is not expired. Otherwise, the query or mutation will not be accessible. All right, so far so good. Now we just can test it. Let's go back to our Auth resolver here. Here we have our hello query. At the moment, it's publicly available without an access token. Here you can see, right? We get back hello world. So far so good. And now let's apply this access token guard globally to our NestJS application. And we can do it by going to our app.module.js. And then here in the providers array, we can provide an object with the provide property here. And here we can pass in a constant called app_guard, which we also have to import from NestJS core. And then we have to provide another property here called useClass. And here we can pass in our accessToken guard like this. And sorry here, this should be of course called app_guard. And at the moment here we get another error. It does not work. And the reason for this is that we are using Passport here. And Passport forces us to use guards with so-called strategies together. And one important thing here is that we have to specify a name as a string. And for example, I can name it JWT here. And now we have to create a strategy called JWT. And we do it by creating another folder here in our Auth folder called strategies. And then here I create another file called accessToken.strategy.ts. And then here again, I make use of the injectable decorator. And then here I export a class called accessTokenStrategy, which extends passport strategy. And then here I have to provide two arguments. The first one is strategy, which is currently not available because we have to install a few other packages. And then here it is important to provide the correct name, and it's called JWT. Because in our accessToken guard here, we provided this string here, JWT. It is important to provide the same string here. And here and now let's install a few other packages. npm I, we need to install passport -JWT, and I think that's it. And now we can import strategy from passport JWT. All right, cool. Now here we can make use of our constructor and dependency injection. We can say public config is of type config service like this. And now here in super, we call basically the constructor of our parent class. We have to provide an object with a few keys. And the first being, we have to tell Passport how to extract the token from the request. And we do it by saying extract JWT, which we have to import from passport JWT. And then we say extract JWT dot from auth header as bearer token. This is how we get the token from the header. And then we of course have to provide our secret so that the token can be decoded. And we named our secret accessToken secret here. So we copy this environment variable name and we pass it in here. And we do not need this option here. If we left this option, we would have access to the request object in the validate method. We can also leave it, it doesn't matter. So we would have access to the request object in this validate method here. And all we do here is to return the payload. And what is the payload? So what basically is happening here, the JWT token is extracted automatically and then it's decoded. And then the result that we get after decoding the JWT token is here the payload. And this is what we return. And this gets attached to the user object on the request object. So we will have access to a property on the request object called user, and this user will have the properties of this payload object here. And I would say, to make it more clearer, let's type it properly. At the moment, we do not have any type for the payload and stuff like this. So let's create a few types to make fully use of TypeScript. So in our auth folder, let's create a file called types.ts. And here we export a type named JWT payload, which is equal to curly brackets, and then email, string, and user ID number. This is our payload here. And why do we have these two properties here? We have them Because if we go back to our Auth service and we go to our create tokens helper method here, we see that we sign the user ID and the email to our JWT access token here, right? We encode the user ID and the email. So whenever we decode the token, we get these two things as our payload, right? All right, let's create another type. Export type JWT payload with refresh token. And this is equal to JWT payload. And then we provide this sign here, this and sign. And here we can pass in an object, refresh token, and then which is a string, like this. So this type here will have these two properties, but also it will have a property called refresh token, which is of type string, right? I think that's it for now. We can close this file. And now in our validate method here, we can delete these two arguments here. We do not need them. And payload is of type JWT payload. We can import our custom type. And now it's a bit clearer. Now we can go back to our playground. And again, here it does not work. It still says unknown authentication strategy. So NestJS does not know about this strategy here. So we can grab it and we can go to our auth.module.ts. And here we have to put it in the providers array. And sorry, we do not have to provide this passport strategy, but we have to provide the access token strategy, of course, yeah, the child class. We have to import it. And now we can go back to our GraphQL playground. And now what we get back is an unauthorized, right? Now this query here is protected, and it is protected because we apply a guard globally to our NestJS application. Yeah, so we can go back to app.module.ts. We apply this access token guard here. And this access token guard checks if a valid access token has been provided here in the headers, right? This is the purpose of our guard. So now we have protected routes. Now we can try out our public custom decorator. We can grab it and we can apply it to our hello query here. So just above here, add public. Yeah, we can import our public decorator here and apply it to our hello query. Now we can try again. And now our route is publicly available without a valid access token. Now let's grab this decorator and also put it above the sign up and sign in mutations. And I would say now let's throw the decorator away here from the hello query. Let's test it again. We are unauthorized. Now that we have our access token guard and our access token strategy, which will work in conjunction, we can go back to our sign in mutation. We can sign in to get a new access token. We can copy this access token. We can go to our hello query, and then here under HTTP headers, we have to provide an authorization key and then a string with bearer, empty space, and then our token here. And if we hit play, we get unauthorized. This is because we can go back to our auth service, and here we see in our create tokens method here that our access token expires in 10 seconds, yeah, which is very short-lived. Let's make it maybe 1 hour. Now we can go back to our playground. Let's sign in again. Let's grab this access token, put it in here, and it worked. So we accessed a protected query by providing an access token here. And how this works is we have a guard here, and this guard works with a corresponding strategy. And in our case here, we provided JWT here. So Passport knows that our guard should work together with this strategy here, because we also provided JWT here. And what's happening is, whenever there is a query or a mutation without a public decorator, then it basically calls this canActivate method here. And then finally, our accessToken strategy here kicks in, and it extracts the token from the auth header, and it provides it as payload in here in the validate method. And this payload gets attached to the request object. The last thing we want to implement is a refresh token mutation, you could say. So every time we hit this mutation, we get a newly created accessToken and also a newly created refresh token. And this is for the case, remember before we ran into the issue that our accessToken was expired here, right? And then we got an unauthorized. And for this case, whenever our accessToken is expired, then we want to have another mutation that whenever we hit it, we get a newly created accessToken and also a refresh token, which is also stored to the database and so on. Yeah, so let's work on this. To implement this refresh token feature, let's create another strategy called refresh token.strategy.ts, and it's somehow similar to our accessToken strategy. So I will copy some stuff and paste it in. And of course I have to do some imports here. Injectable, passport strategy, and our contract service, then extract JWT. So what's happening here? We create another strategy called RT strategy for refresh token. We can name it refresh token maybe. It's a bit clearer. Refresh token strategy. And then we provide the name here, JWT refresh token. This is important because we have to provide the same string to our corresponding guard that we will create in a bit. And then all we do here is, again, we extract the bearer token, same as before. And then we make use of this property here, pass rec to callback, and we set it to true. So now we have access to the request object here in the validate method. Since we have access to the request object, we can extract the refresh token here. And then also we can return the refresh token and then the payload, which contains, remember, the email and the user ID. And then remember, this stuff here gets appended to the request object. So we have access to it. And in this case here, we need this refresh token in order to get a new access token and a new refresh token. Yeah, this is important. And yeah, why we need this thing here, you will see in a bit. This is the difference. Here we need this refresh token, but here we don't, right? And okay, again, I have to import some stuff here. And here I have another error. Of course, this must be a small letter like this. And now it should work. And here it's important that request comes from Express. Like this. Okay, cool. And now that we have our refresh token strategy, let's make another guard. A refresh token.guard.ts. And this guard is pretty straightforward. I just copy some stuff and paste it in. All we need to do is we need to override the getRequest method. Since we are using GraphQL, right? So we need to create a GraphQL context. And then we need to return our request object here. And since we do not want to override the canActivate method, which we did here, right? So we can have some logic here. We don't need it here, so that's it for now here. We are done with the refresh token guard. Now we can go back to our auth service and we can create another method. Async get new tokens, and we need to provide a user ID of type number and a refresh token RT of type string. All right, then we have to find a user by ID. We are using find unique here. because ID is unique, because it's a primary key. So we must use find unique here. And then we check whether we find a user. If we do not find a user, access denied. Yeah, no chance of getting new tokens. For the case that we have a user, we compare the hashed refresh token from the database with the RT that was provided. And if they do not match, then again, no chance of getting new tokens. Yeah, we are done here. Otherwise, if we pass this if statement, we create our new tokens here with this create tokens method by providing the user ID and the user.email that get encoded into our JWT. And then we update the refresh token field in our database. And finally, we return some stuff here. Now we have our service method here. Let's create another DTO here under Auth, because we also need to create another mutation. And for the mutation, we need a DTO. And we name this DTO new token or new tokens response .ts. And here we say export class new token response. And we have our access token and refresh token here. And here again, we need to provide decorators, object type. Yeah, because it's a response, we have to provide object type. If it's an input, yeah, if we receive some arguments, we have to provide the input type decorator. And we have to provide here the field decorator, like this, and like this. So GraphQL is able to auto-generate all the GraphQL stuff for us. Now we need to create two other custom decorators. One called current user.decorator.ts. And here we export a variable called current user, which is equal to create Param Decorator. And here we can provide a function, and this function gets as arguments data, and data is of type key of JWT payload with refresh token. And the data property can either be key of JWT with refresh token, or it can be undefined. And then we can say comma, and we also get access to the context, which is of type execution context. And this import here did not work correctly. We have to go back one folder, I think. And then we are already there. Because types is in the auth module, right? All right. And what are we saying here? We say data is of type key of JWT with refresh token. What does this mean? This means that data can either be email, user ID, or refresh token, yeah? Because these things are the keys, right? And JWT, payload with refresh token, has all these three properties. So this is how we want to type our current user decorator here, that data can only be one of these three keys, right? Yeah. And now what we can say is const ctx is equal to, again, we have to create our GraphQL context here. Please make sure to import it as well. And here we have to import also execution context. Now let's get access to our request object by saying ctx.getContext and then .rec, like this. And for the case that data is undefined, meaning we did not provide anything here, then we just return request.user. But for the case that we have data, which is a string, and as I said, it can be one of these three here, right? So if we have data, then we want to return request.user and then again data. Yeah. So we return user.email or user.id or user.refresh token, of course. Yeah. And I'm sorry, this must be named rec like this, and same down below here. And as you see here, we access rec.user, and this user property exists because of our strategy here, right? Because in our validate, we return a payload, and this payload is basically this user object, right? And because we return this payload here, which contains the ID and the email and so on, this gets appended to the request object. We also could do further logic here. We could fetch the whole user from the database and then return it from there. So we would have more properties, but for now we just have the ID and email, and yeah, it's enough. Okay, now let's create another decorator, and let's name it current userId.decorator.ts. And this decorator is pretty similar. We just copy the current user decorator and we paste it in here. We name it current user ID. And here we do not expect any arguments, so we delete all this. And here we just can say underscore colon undefined. Yeah. So we do not provide anything here. And then here we just return user.id. And we do not have this data here. And we can delete the last line here. All right, so far so good. Now let's go back to our auth resolver. And here we can implement another mutation, which returns the new token response. And we name this mutation get new tokens. And in here we return this .auth service get new tokens. And get new tokens expects a user ID and a refresh token. All right, for now we do not have these variables. And how can we get them? Yeah, it's quite simple. We can use our Params Decorators that we have created. @ current user ID. And this decorator does not expect any arguments, right? Remember, we just said underscore is of type undefined. So this does not expect any arguments. And then we can say user ID of type number, like this. Next, we can use our other decorator, current user. And this decorator expects an argument. And here I provide refresh token. And then also we extract the refresh token here. And why can I pass in refresh token? If we go back to the current user, you see that I expect an argument, and this argument can be key of, yeah? And these keys are always strings. And I pass in refresh token as string. And since we provided refresh token as argument, we are in this if statement here, and we return rec.user refresh token. And we have access to the refresh token here because in our refresh token strategy, we return the refresh token here, you see? And this is why we have access to the refresh token, because we return it from this strategy here. And remember, whatever we return from this validate method gets appended to our request object. And this is why we can access the refresh token here, yeah? Because it's available under rec.user and then refresh token. And now we have just to make sure one thing. We have to go back to our auth resolver and we have to make sure that this get new tokens mutation is public. And this must be public because whenever we hit this mutation, yeah, we do not have a valid access token because it's expired and we only have a refresh token. But in order to access non-public queries or mutations, we need a valid access token. So we need to make sure to make this public, that we can access this mutation without a valid access token. All right, now we can test it. Let's go back to our playground. Then here under sign in, we can sign in again, and then we can copy this refresh token here. And then we can create another tab here with a mutation. I named mine refresh, and then this name here matters, right? Our mutation was named get new tokens, yeah, which you can see also here. And then it just returns the access token and the refresh token, and it does not expect any arguments. Now I need to make sure that I paste the valid refresh token in down below here. Make sure this is a dictionary here, yeah. And you need to provide the authorization key here as well. And then you need to provide a string with bearer empty space. This is important. Now let's hit play. And here we have another error. And I think we have this error because we need to make sure that we grab this refresh token strategy and put it in here in the providers array. All right. Auto import does not work. Not nice. But we can import it like this. And guys, of course, I made a mistake. I think you might have already recognized it. Here we need to apply our guard, right? Use guards and then refresh token guard like this. And by doing so, yeah, we are making use of our refresh token guard and our refresh token strategy here. And this refresh token strategy makes sure that a user object is available on our request, yeah. And by doing so, this thing here should not be undefined anymore. And yeah, let's give it a try again. And here we get another error. How nice. And it seems as if our find unique method did not get an ID, a value for the ID. And I found the mistake here. If you go back to current user ID.decorator.ts here, we must change this from ID to user ID, like this. And now let's try again. And of course, we need to change it down below here. And hit play again. And now finally it's working here. Beautiful. And just forget about these things here. This is just from console.log. So don't get annoyed by this stuff here. And yeah, the mistake was the property here, user ID. And why is this named user ID? It is named user ID because if you go back to our auth.service here, and you go to our helper method, create tokens here, yeah, we named it user ID. We named it simply user ID, that's why. So whenever we decode a JWT token, we get back these two properties here. In order to be a bit more type safe, we can go back to our user ID decorator here. Where is it? Here, current user ID decorator. And here we can say the following. Const user is equal to request.user and then as JWT payload. Like this. And now we simply can return user dot, and now we can choose user ID. Yeah, this is a bit more type safe now. We are making use of TypeScript. Yeah. Since we are using TypeScript, we should do it. And yeah, that's it. Maybe one important thing here. You see that we did not provide any arguments here to our get new tokens mutation, right? We just provided this refresh token here. And we didn't need to provide any arguments here, such as user ID, and so on, yeah, and the refresh token. And why this is because in our auth resolver, we did not make use of this args decorator here. Whenever we use this args decorator, we are expecting some input, yeah, from the user, from the client. But in our case, we just made use of two Params Decorators, yeah, that we created ourselves. These two decorators work because they access the user property on our request object. And this user property exists because we are making use of our strategies here. And these strategies, they extract the JWT from the header. So they extract this thing here, right? They decode it. And of course, they also check if it's valid, yeah, if the signature is valid and stuff like this, and if it is not expired and so on. And if it's not, then we get the payload here. And the payload is basically what gets appended as the user object to the request object. Yeah? And this payload can contain some user properties, yeah? As ID and email, for example. But in our case, we named it user ID, right? This is what we encoded in our JWT. And this is how we get access to the ID and to the refresh token. And we need these two arguments for our method here, right? Get new tokens. We take the user ID to find a unique user, to find one user. If we do not find a user, we throw an exception. And for the case that we find a user, then we compare the refresh tokens, right? And if they match, then we create new tokens and we save, of course, the refresh token to the database. And this is how it's all working. Guys, I hope it was helpful. It was very hard for me somehow. I tried my best to explain it as well as I could. I hope it was a little bit helpful. If something was unclear, please hammer down questions in the comments down below. I will try my best to answer them. Yeah, thank you so much for watching and see you in another video. Bye for now.